Alright, so this is our team bike. We're from Arizona State University, and this is currently what we have. Unfortunately, with how the situation has been with COVID-19 and labs shutting down and us not having access to proper tools, things went a bit haywire and not according to plan. So we had to improvise with what we had, basically using hand tools and other various things to get certain components mounted and on to the bike. So we're going to start here with the reservoir. We tried, this is made from a 22 gauge steel. We tried soldering it, we tried brazing it, we tried welding, but none of it was working. And so what we have here are L-clips bolted on and sealed with JB weld. And as you can see, it's also mounted here with a metal pipe clamp and a piece to support. Over up here we have a drain plug as well. And we have two lines going out. And we have a return line up here with an air filter and a fill port. The accumulator mount back here, we have two large U-bolts with foam insulation to hold the accumulators on. That's attached to a piece of 16 gauge steel. We have this frame here we ordered on Amazon. Underneath here we have a metal clamp to hold this top plate on to the bottom like such. And obviously that's bolted on here. The manifold mount. So this is taken from a bent up, cut up, just random piece of scrap metal. This was initially our temporary mount, but again, given the circumstances, it just so happened to become our permanent mount. And then lastly, we have the pump and motor mount. The pump mount is pretty straightforward. It's just a flat sheet of 16 gauge steel that has the hole cut out and the bolt holes for both the pump and the motor respectively. We also have these spacing clamps here to hold it onto the bike frame. And there's also a third attachment point back over here where these bolts are. This being a flat piece that is assumed to be parallel with this pedal assembly up here. That way the pump and also the motor sprocket would be lined up. The chain is not currently on there because of just kind of the whole configuration of it. But we have the motor sprocket back here attached onto the rear chain assembly. Had to grind that off and slap that on there. And that concludes the fabrication.
Okay, so for the first of our drive modes, we have a direct drive, which is essentially you have your fluid sitting in your reservoir. The fluid is then being pulled as you pedal because the pump is siphoning out the fluid. That fluid would then be going into the pump. We have it placed lower than our reservoir, essentially so it can easily accept the fluid. So essentially it's taking in the fluid from this line, which is coming up to the reservoir there. It spends the fluid as the operator is driving the bicycle, and then it's sending that fluid to this bottom line, all the way up, tucked away, looped around, and then back into that P1 port. And then as we follow back around to the chain of things, in the manifold, that fluid from that initial port is being sent into the motor inlet from this P2 port. It's being spent at the motor to the wheels, and then it's being exhausted out of the motor from this top port all the way back up, and then you follow it back into this T2 port. Okay, lastly, the good thing about direct drive is that the system is set up in such a way that if there were any electrical failure in the system due to just a low power supply or just a short in the electrical circuit, the system can still be safely operated without use of engaging any solenoids in the manifold itself. Okay, so for our accumulator discharge mode, essentially we have an ideally filled and pressurized accumulator that we would like to dispense to the wheels. We would do so by engaging the discharge mode through the ECU. That would send the fluid down into this line and essentially would go into this port P3. That's gonna go down into this port P2, being sent back to the motor all the way through into the in port, and then essentially this would be engaging the wheel, being sent back into the out port. You go all the way up again, and then you enter the port T2 on the manifold. That's going to be cycled into the manifold, back into the T1 port, where it is then cycled around this bottom line. It goes up on this side, and then it's sent back into this hybrid line that I had mentioned earlier. And then it's successfully returning back into the reservoir, having achieved a safe discharge mode. And then one thing I actually left out, if for some reason you did not want to successfully expend accumulator pressure to the wheels, we have this line body with this mechanical needle valve implemented onto it, so you can safely expend this back into the reservoir if need be. And then that would be essentially through this top line. And then you could safely discharge that way as well. So. Alright, so moving on to our regen mode. Essentially we have a hybrid line. It's basically a return and a suction line in our reservoir out the front. So in our regen, essentially the motor is being engaged. It's still in the circuit, so essentially the motor's connected. So you have your line coming down, follow the line all the way, wrap around, and then that's going into port T1. The solenoids would be engaged in such a way that they're sent through the manifold into P2, and then you follow that line all the way down, all the way up and around, and that's going into the motor, out of the motor. You follow it back up and around, and then you go into T2. So then this keeps the motor engaged into the cycle, excuse me. And then you follow that through the manifold. It's again engaged in a way to have this back port P3 open, and then the fluid will be sent all the way through, and then follow that in. It's going to be going into this line, which is going to essentially be going back up into the accumulators, having successfully achieved a perfect regen mode. Alright, so for our unique hybrid drive, if you follow me, essentially this is a system where you can disconnect the motor. You can use that continuously cycling fluid in the motor to the wheels, just to freely let off any sort of pressure, and then you can also directly charge the accumulators this way while this motor is still cycling. So essentially you have your motor, or your pump, excuse me, engaged by your driver. You're following this line that's sending fluid back into the manifold. Obviously the fluid being pulled from that reservoir. Same port from our direct drive mode. And then the solenoids within are engaged in such a way that the pump and the motor are disconnected, and the motor is pulling its fluid from this bottom port, and it's sending its fluid back into T2, and then that leaves this back port, this P3 port. This would be open essentially, and then that wraps around, and then you can successfully charge your accumulators this way. It's going to be sent through this line and then up into the accumulators, and we can have an accumulator charge while the motor is still continuously running. So that's what makes the drive mode unique.